In this video, we'll talk about Internet of Things applications in logistics. Maybe you still remember earlier we mentioned that logistics is actually the place where Internet of Things was born. At the beginning, Internet of Things was developed based on the development of RFID, the radio frequency identification. Basically, at that time, people would like to attach a RFID tag to everything. Or in the logistics, including the goods, including the vehicles, including the cars, including the containers and cargoes. With the RFID tags, basically the movements of these items can be checked and traced all the time. So that's where Internet of Things, this term was used. But later on, so the focus of Internet of Things has been broadened. Basically, people are moving more towards the application of sensors and actuators to make smart actions and interactions with people. But anyway, so Internet of Things, this term was originated from the logistics, and now it is a little bit different from its original definition. So what's logistics? It is a concept which is related to the movement and transportation of tangible goods or assets. And in order to understand the term and its related concept, it's useful to look at typical enterprise organization which produce physical goods. So because logistics is dealing with the movement and transportation of tangible goods, so sometimes, well, now we have the e-commerce, right? Digital commerce. So if they are not producing the physical goods, so the logistics may be, well, maybe just a small portion of it, or maybe they get rid of logistics for a majority of the process. Yeah, so in that case, as we discussed later, sometimes the movement of people can be considered as part of logistics. Okay, but basically when we talk about logistics, we focus more on the physical goods. So the importance of logistics in the overall enterprise operation varies significantly and depends mainly on the cost of the end goods. So this is something you may have not noticed. You may know that logistics is very important, especially when you're using a UPS, using a FedEx. Actually, it is a logistics service, right? But you may not know that the importance of logistics is related to the cost of end products. So take your notes here. The value of logistics in an enterprise producing low-cost goods is greater than the one for an enterprise producing high-cost items. So both types of business use logistics as an essential part of operation. The interesting part here is that low-cost goods, they rely more on the logistics. So the reason is that for the high costs, the revenue margin is high, right? Because for example, if you are buying a limited version of a pair of shoes, in that case, because the cost of the item is already high, so the manufacturers or the producers can ask for a large margin of revenues from the product. For example, the raw material, the production cost is $5,000. So most of the time they can ask for another $5,000 as the revenue margin they can get. But if you are just producing bottled waters, for example, so you can buy 24 bottles of water, maybe using $3-4. In that case, for these bottles, then maybe the manufacturer can only earn maybe 20, 30, 40 cents from these waters. In that case, and because you cannot ask for $20, $30 for the waters, which cost only $2 or $3, right? Because if they ask for that much of money, basically their competitors will defeat them immediately. Basically, the low cost of the products will limit the revenue margin they can ask for. In that case, if they can reduce the logistics cost further, so they will get some advantages during the competition. Otherwise, they will be in a bad loop. position in the competition. So for the logistics, the process usually looks in this way. So enterprise that produce tangible goods typically collect raw material and constituent parts or components, right? So sometimes if it is the raw material, just like cooking, you pick up the vegetables, tomatoes, and also you have some constituent parts and components, just like the cheese, right? It's not raw. It has been processed somewhere so that it is cheese, right? And then the enterprise will manufacture the products and goods and potentially store the finished goods in a local warehouse and finally dispatch the finished goods further to be stored and sold to customers. So that's the basic scenario of logistics. So let me show this figure to illustrate. So we have raw materials from a larger number of vendors, suppliers, and some of them will be processed into components. For example, if you buy a car, right? So you see for the car company, usually they don't buy. Usually they will buy some existing products from other vendors. For example, the lights. For example, the windshield. For example, the maybe the tires from other vendors. So they don't need to deal with the rubber. They don't need to deal with the glass from the very beginning, right? In that case, they obtain raw material as well as components, and then they do the manufacturing. After that, they have some distribution center to put the finished products. For example, they may have a center in North Carolina, and they will have a center in Virginia, for example. And in order to let the products go to the hands of customers, they need to have the retailer store, right? Basically, if it is talking about vehicles, then we have the dealers. So actually, there are many dealers around North Carolina. So in that case, the cars will be distributed to different vendors, not different vendors, different dealers within the state. So that's how the process is working. So in that case, we will have two flows. So we'll talk about them later. Basically, they are flowing in the opposite direction. So to guide our discussion in this chapter, so we will first try to define logistics management as well as supply chain management first, so that we know their relationship and we can make our discussion more focused and accurate. So before we move to the next slide, can you guess which is a larger concept? So is supply chain a larger concept or logistics a larger concept? Okay, so if you don't have the answer, don't worry. So we will see very soon. In this concept, the term supply chain and supply chain management are essential to understand, since SCM is often confused with the term LM. LM stands for logistics management. So the definition of SC is here. It is a network of connected, and I will leave the reading to you. Basically, have the definition of supply chain here. So for the definition, it is important to note not only the flow of physical materials, components of finished products is concerned in the supply chain, but also the information of flow, the reverse flow of information from customers towards the manufacturer and the suppliers. Basically, we have the supply flow, which is the physical materials, and also the demand flow, which is the information flow, right? Basically, from the customer, we will go in a reverse way that, okay, from the retailers, we tell the distribution center that, okay, how many vehicles, for example, we need from this retailer, from this dealer, and this distribution will then inform the enterprise how many cars you need to produce, right? Enterprise will inform the component provider as well as the raw material provider, okay, how many raw material, how many components we need. So that's the inverse direction of the information, which is shown here. But for the materials and the physical components, it's flowing from left to right. So those are the two flows in supply chain management. So the ideal situation is that manufacturing enterprise will operate in such a way so that these flows are in equilibrium. In other words, manufactured goods are produced at the appropriate time with the right quantity so that they can satisfy the demand and operate other parameters such as the cost and the finish time and the time to market. Basically, in the ideal situation, we hope that we can produce what are needed by the market, right? We don't produce. In that case, we cannot sell all our products. We don't underproduce. In that case, that means people are asking for the goods, but you cannot produce. Basically, you are losing the opportunity to earn more money. So that's not good either. So the ideal situation is to reach an equilibrium. But of course, this is hard to achieve, right? Due to changing demand and also take risk to predicting the demand with respect to quantities, and this will incur some costs. But we just know the ideal situation we want to achieve. So just now we talk about what a supply chain is. So in that case, supply chain management is the management of upstream and downstream relationship with suppliers and customers in order to deliver superior customer value as least cost to the supply chain as a whole. Basically, we want to achieve an equilibrium we mentioned just now. So if we can do well in this part, we will have competitive advantage. Okay, that's for supply chain and supply chain management. So now let's come to logistics. So we have a definition of logistics from supply chain management and professional. Anyway, logistics it's quite long here, so you may want to read it yourself. But after reading that, we can find that this definition includes inbound, outbound, internal, and external movements. Basically, it's talking about movements. And further on, we can identify that logistics management is a part of supply chain management. Why? So let's look here. So for supply chain management, we need to take care of the sourcing. Basically, we have some third party to deal with some process, and also the procurement, conversion, coordination, collaboration, and logistics management is one of the components. So by looking at this figure, we can know that logistics management is part of the supply chain management. So I hope that you get the answer correctly earlier. With the figure, by looking at the figure, so supply chain management is defined as this way. So it is supply chain management is the ultimate goal of an enterprise rather than the standalone efficiency. So some activities of supply chain management such as procurement and conversion are mainly business related, and it is now closely related to the topic of Internet of Things, while the logistics management activities and other SCM activities such as sourcing are more related to IoT. So that's what it talks about is that logistics management and also the sourcing, they may be more closely related to IoT. So as a result, this chapter focuses more on the logistics management rather than the whole supply chain management. So I think for this semester, maybe Dr. Andy Ham is teaching the supply chain management course. So I think it's also an interesting course. But for this chapter, we'll focus on how physical assets of a supply chain are flowing through the supply chain from suppliers to manufacturing enterprises and towards the consumers and customers. In this process, we may have other assets to facilitate this flow, including the transportation means, the material components, and finished suitable storage. Okay, now let's look at the roles and actors in a supply chain. So that we can know that where Internet of Things applications can play a role among these roles and actors. So first of all, we have the raw material providers, right? Basically, if you are cooking, basically they are the people who are selling the tomato, potato, spinach, something like that. And we also have the intermediate component providers. So they are selling some products that have been somehow processed. For example, then if you are cooking, then they may be selling the cheese, they are selling the spaghetti. Basically, they are already processed, right? And for manufacturing, so the raw material may be selling windows, right? No windows, glass. And for the intermediate component providers, they may be selling the lights. They may be selling I don't think they're selling engines, but they're selling maybe the seats. So it's part of a car, right? And of course, we have the manufacturing enterprise. Basically, if it is manufacturing a car, that is the manufacturers like Toyota, like Honda, like what do you have? GMC, something like that. And then after the finished products are completed, we need distributors to to send the finished products to the national or the global markets, right? Because the ultimate goal of creating physical products is to sell them. By the end of the day, the people, like you and me, the ordinary customers, usually we don't interact with the distributors. What we do is to interact with the dealers if we are buying cars, or we are interacting the supermarket, grocery stores if we are purchasing foods. So we need to have retailers. So in that case, we will have a large number of retailers so that the finished products can be accessed by a large number of people, right? And you and me, are usually the end consumer users. And during this process, we may also need transportation providers, because as the raw material, the components, and the finished products are moving among these rows and actors, we need something to move them, right? So in that case, transportation providers is also important during this process. And just keep in mind that real supply chain, not all roles exist. It is possible. So there are no distributors if the manufacturer dispatches all the finished goods directly to the retail stores or customers, right? So basically, some manufacturers are promoting this model, because when the finished product move from one row, one actor to another, usually the price will go up a level, right? So basically, the distributors need to earn some money, right? So that they raise the price a little bit. Then the retailer need to get the products from the distributors, and also they want to make money, so they need to further raise the price over the distributor. So basically, the price may be lifted twice, at least twice, right? But if the finished products can go directly from the manufacturing enterprises to the retailers, so there is only one transition, so the price may be only lifted once. So one observation is that the transportation, storage, and warehousing and inventory activities may be performed by manufacturers and retailers and outsourced to other parties. So this is a very common term, the third-party logistics providers. So the definition is here: outsourcing logistics operation of company to a specialized company. Basically, for example, when they move the raw material from the producer to the manufacturing enterprises, so they will they will pay for a fleet of vehicles to do the transportation, right? So that they don't need to in a fleet themselves. So they don't need to make sure that all the vehicles are working. So that can help them to reduce the cost. Instead, they just like you go to the moving help. Yeah, I'm moving to a new house anyway. Just like you go to the website and go to the moving help and rent the U-Haul. And sometimes you can also hire 2 strong people to help you to do the moving. So that's outsourcing, right? It's third party. So one question you may have is that, okay, it's third party. So what are the first and the second party, right? So it's here. The term first party refers to companies that have a first order interest in the product. In other words, the manufacturer or the retailer. So that's the first party. Second party concerns the company that are typically used to carry these products, for example, different carriers, like by land, air, and sea. So it's like, so for example, for air, right? So you may want, a manufacturer may want to ship their products to another country. In that case, they need to use planes. So instead of dealing with the flight companies directly, so flight company in this case is the second party because they provide the direct transportation, right? The means of transportation. But you know that there are many procedures, there are many regulations when you're doing international shipping, freights. So usually a company will once again find a third-party logistic provider. Basically, they just need to tell them what they want to ship and how they want to ship. Then the third-party logistic provider will contact the flight companies. They may also contact other sources and basically do the arrangement of yourself. Do all the arrangement for the manufacturer so that they don't need to, spend a lot of time and effort to do this way, to get the products shipped. It is also just like like traveling. So if you go to a country, go to a new place to travel, some people like doing DIY. Basically, they go to the internet and search for for some posts, for some traveling stories, and then go to the location, buy the ticket, or rent a car. They do DIY, right? And some people, maybe senior people, they don't have that much time and energy. They may have time, but they don't have that much energy to digest the large amount of information on the internet. What they will do is to find a traveling agent. Basically, they just tell them where they want to go and when they want to go, right? And also the price level. Basically, the travel agent will deal with the hotel, the flights, and also the tickets of the places of interest, something like that. Basically, that's like a similar role of the third-party logistic provider. So the main characteristic of a third party is that it is a different legal entity from the main interest parties. So the difference combination of transportation and warehousing services is so large that there is no clear definition of third party apart from a general one. So in addition to the transportation, the warehousing, basically the storage, is also a popular third-party provider, right? Because the companies may not want to maintain such a warehouse. In that case, they will just pay an amount of money and use those storage services. So when I'm driving on the street, I saw many storage services. Following this discussion, so now we have third party. So sometimes we may also have fourth party and fifth party providers. Basically, the third party will outsource some of their services to another party. In that case, that new party is fourth party. But maybe if there are too many parties involved, so sometimes the reliability may be not that good and the communication and the coordination may be an issue. But anyway, third party is quite popular nowadays. Okay, so now that's the overall operation of supply chain and logistics. Now let's look at the role of IoT during this process. So logistics, so IoT is enabling cost-effective monitoring and control of real-world things. And logistics are also concerned with the physical movement of materials, components, and finished products, as well as the reverse flow of information. So as a result, IoT could contribute logistics in automation of at least the reverse flow of information. Basically, we can know where the demand are and where our assets are, where our goods are, right? And IoT can also affect the normal flow of physical assets. Remember that for IoT, the two keywords is to monitor and to control, right? And if it is in the context of a logistic, then monitor means comes from the reverse flow of information, and control is dealing with the normal flow of physical assets. For the Internet of Things in logistics, now let's look at the things in this concept. According to a survey, the cost of logistics is concentrated in three activities. So transportation of goods, inventory, and the storage and warehousing of the goods. So inventory is I think these three words are straightforward. So the potential assets depending heavily on the industry. The potential assets for logistics scenarios are the following. So we have the product-related assets, basically raw material, components, finished products, and production machinery. So that's what we want to monitor, right? We want to, maybe some of them, for example, machinery, we want to know where they are, whether they are functioning, and something like that. And for the raw materials, we want to, if we are now in a shortage of some material, we want to know when it will be coming. And also, if some components we have are having some quality issues, we want to know where they are from so that we don't order them again, right? So these are the product-related assets. We also have the storage warehouse-related assets. So straightforward, the warehouse and storage facilities and warehouse machinery, including the forklifts, robotic trains, those kind of things. That's something we also need to monitor, right? For example, the warehouse, we want to know how much room is already occupied. For the we also want to know how many forklifts are functioning, so that we can estimate how fast we can complete the storage. And we also have the transportation-related assets, basically means of transportation, including trucks, trains, airplanes, and transportation medium, as well as the roads, train trucks, sea. That's something I didn't before. So for the sea, we need to know the weather, for example, right? And some people also consider human personnel as one of the things. And in this case, the high priority is the safe working environment, right? So we want to make sure that people can maintain a good distance from the hazardous areas. For example, the type of assets involved in logistics implies that logistics scenarios involve in technologies and typical scenarios from other use cases. For example, the fleet management, commercial building automation, and manufacturing. What it means is that logistics, due to its broad coverage, it may have some elements for the IoT applications in other scenarios. For example, because we have warehouses, storage rooms in logistics, right? So it may be related to commercial building automation, right? So we have the machinery in logistics. So it is related to the manufacturing scenarios, which we talked earlier. So the core of logistic use cases lie in the physical flow of goods from suppliers to retailers and finally to customers. So supply chain is also about the reverse flow of information as before. So the advantage of today's communication infrastructure is that information flow can occur at much higher speed with electronic documents following standard electronic formats, which are machine readable. Basically, now with the implementation of RFID technology, people can always check where, for example, where a component is from, when it is transited. Just think of your FedEx mail, right? Basically, you can use in your browser to check when it arrives at a place, when it departs a place, and it's very convenient now. So that's the advancement in the information flow. So you can imagine that this technology can be used to check everything involved in the logistics, basically the three types of assets we mentioned earlier. So earlier in this video, we mentioned that Internet of Things. This term comes from the logistics. So in that case, we need to talk about organization, which is the JS1 standard. It is a global organization that focuses on the standards for supply chain and business to business information exchange, for large industries such as retail, healthcare. Basically, they standardize product barcode on all the EPCs. EPC, they are the codes used for RFID. So barcode, you know it, right? So it is standardized by GS1. And with the introduction of RFID, now they also standardize the RFID code, and then it is called electronic production codes. Basically, it looks in this way. In other case, in that sense, so each RFID tag is supposed to store a series of numbers like this, following a specific standard to indicate the product. Basically, it is just like your ID. Give you an ID so they can be referred to during the whole movement process. So the GS1 family of standards, no matter the barcode or the RFID electronic production code, focus on identify the products to be transported. We know what it is, right? Capturing the identification information as the product flow in the supply chain. Basically, it will catch the information and also sharing the resulting information about the product flow from suppliers to manufacturers. So it means it will give an identity to the product. And this identity can be captured when the product is moving, for example, using RFID or using the barcode. So both of them can be automated, right? And also this information can be shared. Basically, there may be a reader at the entrance of a warehouse. So when I'll just think of you go to buy new clothes in the shopping mall, right? So if you forget to process a tag in your new clothes, basically when you go out of the store, it will give you an alarm, right? So that's actually an application of RFID information. So you can imagine that when the clothes get in and get out of the store, it can be recorded. The rest of IoT technology on the other hand focuses mainly on monitoring several center and control of application relevant modalities. So once again, IoT focuses on monitoring and control. That's why I said earlier that now the concept of IoT is broader. At the very beginning, it is more related to the IoT, more related to the GS1 functions here. But now with the advancement of the sensors and actuators, so monitoring and control of the process is possible. And as the set of assets of things identified in LM is larger, the non-GS1 IoT technologies can be used to enrich the simple track and trace use cases. Non-GS1 IoT technology, basically the sensors and the actuators. But when we talk about GS1, it's mainly related to what? To the barcode and RFID. So the assets identified in the logistics are two main categories. So the products, items, goods, which can be monitored with sensors. And the use of actuators of such assets is limited but not excluded. And introducing sensor technologies in addition to the barcode and RFID actually enriched monitoring of goods in the main, and it's the main focal area of combining GS1 and non-GS1 technologies. So in addition to barcode and the RFID, now we can use different sensors to monitor the goods, right? Okay, the second category is the relevant and involves assets from the transportation and storage of the products, as identified earlier. So the use cases later in the chapter attempts to capture the use of both category of assets. So in that case, we have the products, goods, as well as the transportation and the storage assets. So the combined monitoring of the whole supply chain typically enables better visibility and control of the supply chain than automating just a part of it. And during this process, we need analytics and machine learning tools, and sensor data can reveal a certain type is exposure to temperature outside the normal range for some time, and the result is that the supply state may need to be updated dynamically. So that this example shows a combination of GS1 technology maybe RFID or barcode. Basically, we know what the product is, right? But also we have the temperature sensor and also the timer, yeah. So that we know that to what the product is exposed and for how long, so that we can update our information. So there are numerous logistic use cases in the literature, and for our case, we look at the food transport because it is a very typical example, and also it's where the previous IoT technology, the small version, okay, is initiated. So the use cases focus on physical goods products and more importantly, food transport around the globe. The motivation is showcase multiple modes of transport, the aggregation, degradation of items, bottles, pallets, containers, and the transformation of raw material to good items. So it is a ready meal food company in country A. In this case, I will leave the reading to you. So basically, it describes the whole process where the raw materials, vegetable, proteins, oils are aggregated together using different transportation methods to the food enterprise and processed and distributed for several layers. Basically, from a container to a pallet, and then from pallets to boxes. And during this process, different transportation methods are involved. And finally, the finished products will reach the retail and wholesale. Yeah, I will leave this part to you. And this figure shows the layout of the manufacturing enterprise. Basically, it is here, okay, for enterprise. So usually there are several regions or zones used here. So we have the loading docks for raw material, which is zone A. And basically, when material move from zone A to zone B, be for example, sensors, RFID readers, or, to update in the background system so that we know, okay, this number of raw material, this number of tomatoes arrived at what time, something like that. And also with the RFID code and also the data management system, now we hope that we can trace where those tomatoes are from. Basically, we can trace the tomato from its birth. So that's the ultimate goal. So if something wrong, for example, if some poison events happen later, then we can trace back to the origins of all the components, all the raw materials, so that we can find out the source. So if something bad happened and we don't even know where the tomatoes are from, so basically that will put an issue on the food safety, right? Okay, and after the raw material has been stored in zone B for a while, so we move to the manufacturing process. So that's related to the automation we talked earlier when we move into the case studies. And after it is processed, we'll go to the packaging and storage room, and then it will be distributed. So basically, you see there are some boundaries here, right? 1, 2, 3, 4. When the raw material or the semi-finished products cross these boundaries, so there will be readers or sensors to capture their data, to identify them and share the data with the system, so that we know we know everything about the raw material as well as the finished products. The following slides basically describe the process into more detail. So I will also leave this reading to you because it's just like telling the story how the items are moving from zone A to zone B and how RFID tags and barcodes play a role during this process and how the IT system is updated and controlling the process.